Good afternoon, everybody. Welcome back to Math 30-1. It's certainly not the same as being in class and seeing you face to face and talking to you one-on-one, but we're just going to have to do the best with what we have. I hope everybody is doing well and is healthy, and your family and everybody who's close to you, your friends are all healthy and happy as well. I really miss you guys, but this will have to do for the time being. So if you've linked to this video, that means that you've gone into Google Classroom and you've read today's post. So what I'm going to do today is go through some expectations that I'm going to have of you over the next 3 months. And then we're going to be doing a bit of review of some trigonometry that we learned previous to this whole fiasco taking place. And then you're going to have the first of many assignments that you're going to have to complete and turn in for marks. So to begin with, this is only a 3-week schedule, and what I will do for this whole remainder of the course, which I'm calling the rest of the story, is I'm going to provide the plans to you and the schedules to you in about 3-week chunks. So if you were to count the number of lessons that we have here, or the number of days where something officially is going on, there's only 8 of them, and yet there's about 15 days in this time period that are school days. And that means that there are going to be many days where there's not a video being taught, but there's still going to be an expectation for you to do some things on those days, and we'll get to that in a bit. So you can see the topics that we're going to be covering. The note packages that I've provided to you in school when we were in class, you don't even really need to worry about them anymore. We're going to be going with this new note package. Whenever I give you this kind of mini part of the whole remainder of the course, I'm going to provide assignment dates to you. So your first assignment will be made available to you today, and it's due on April 6th, which is Monday. And your second assignment is going to be made available on April 9th, and it's due on the 14th. On those days where there's not a video or there's no instruction taking place, you're going to be able to use your class time to work on materials that have been assigned. And every day from 12:25 to 1:50 p.m. during the week, if you go to this link, this hyperlink, you'll get to a Google Hangout, and every day that's listed here, April 3rd, 7, 9, 13, 15, 17, and 21, during that time, I will be logged in to that chat room. It's a video chat room. So if you log in and you have a webcam on your laptop or computer, I'll be able to see your face. I will probably be in presentation mode, which means you won't see me necessarily, but you will see what's on my computer. So it will be just like being in class, where typically when we start the class, if you have questions, you can ask me what the answers to those questions are, or how to do those questions, and that will be the exact same thing that will be taking place here. If somebody has a question, I'll be going over the question on the board, and you'll be able to follow my work on a smart board that will appear on your screen on your computer. If you cannot, for some reason, be there during that time, but you do have questions, you can certainly email me and we can make alternate arrangements. So there'll be lots of opportunity for us to speak one-on-one with each other and help each other out. You already know where the shared classroom folder is. There's the link to that. If you ever need any resources, if you need some software for a project that we're going to be working on, or you need a copy of the formula sheet because you've lost it, or you've lost the unit handout, you can always find that information there. Every day I'm expecting every student to go into Google Classroom, because every day by 8 o'clock I will be making a post. I will be posting something. It might be like the post you read this morning, which basically said, look, here's what we're going to do today, and I provide you with a link to this video and a description of what it's going to be about. Or the post that I will have tomorrow will be a reminder, probably, of the written response that's due next week. By the way, tomorrow we're moving on, so that's not entirely true. The post tomorrow will be a post to a new video link. And then on, I guess it would be Friday. Friday, we're not doing anything new. That post would just be an explanation of where we're at so far. But because things can change very rapidly with this online learning, I do want everybody to log in to your account every day and go to Google Classroom and see what's happening every day. Now, I know that many of you are concerned about your marks. Many of you have emailed me already. First of all, you need to understand that every time Alberta Learning or Alberta Education says something to be the case, they can change their mind at a later date. And over the past 3 weeks, with regards to grades and passing courses, they've changed their minds a number of times. The current statement from Alberta Learning is basically saying that if you are in a passing situation when this whole thing started, then you will pass the course. However, we've decided in the math department that we are still going to continue to mark you and evaluate you in percentage form. Alberta Ed is saying it's up to schools to decide how to evaluate students, and I just don't want to get to the end of all this and have Alberta Education say, oh, by the way, you need a percentage for all of your students, and yet all we've been worried about is pass-fail the whole time. So we are going with a percentage system. The mark that you had as of April 1st, today basically, 40% of that goes towards your final school awarded mark. Your weekly assignments, and you will probably have one assignment every week on average, are going to be worth a total of 40%. And then near the middle to the end of June, you're going to be given a final assignment, which is due near the end of June, and it will be worth 20% of your final mark. The diploma exams for June have been canceled. If for some reason, and I can't think of a reason why you would want to, but if for some reason you do want to write the diploma exam, you can make a special request to do so through the school and through the government. All right, so we're going to move on here and get started with a bit of review. We're going to spend maybe 15-20 minutes here reviewing coordinate trigonometry. I'm calling this coordinate trigonometry the second coming, and we're just going to do 2 examples to try to refresh your memory as to some of the things in trigonometry that were important. And then you're going to have a written response question, which is due, I believe, next Monday. So we have 2 examples. The first example says determine the general solution to this equation, sine of theta equals negative 0.8, where theta is in radians, and your answers are rounded to the nearest hundredth. So we need to remember something about a general solution. A general solution is any angle that has that sign. And basically, if we can find the angles that have a sine of negative 0.8 from 0 to 2 pi, if we can locate those angles, then all we have to do to get a general solution is add multiples of 2 pi to those numbers, and that will be a general solution. So we have to start off by finding what's called the reference angle. And the reference angle is found on your calculator by taking the inverse sine of positive 0.8. This is just a reminder that you never enter a negative when you go inverse sine or inverse cosine or inverse tangent. So what we get for a reference angle needs to be in radians. We're asked to come up with an answer in decimal form in radians, and the simplest approach is for us to use our calculator. Make sure our calculator is in radians. So I might have misspoken a minute ago. I think I might have said we're asked to find a reference angle in radians in decimal form, but we're actually asked to find the general solution, but that means we have to start off with a reference angle in radians. So I'm in radian mode. I'm going to take the inverse sine of 0.8, and I get a reference angle of 0.9273 of 0.9273 rads. Now it's difficult for me to visualize exactly what that angle is. It would be nicer if it were in degrees, but that doesn't change the fact that it has to be in radians. So that's the angle that we are dealing with. And now the second step to this problem is for us to identify the 2 quadrants that the rotation angle could be in. Now when you go back and you look, this is your eyeball, and you look at the value of the sine of the angle is negative. And you know that sine, and this is going to be important for the next question we do, sine of a rotation angle is a y coordinate over the length of the terminal arm. And the only way that the sine can be negative is if the y coordinate is negative. So the second step is to say that we have this reference angle, and now we know that that reference angle can be in quadrant 3, or that reference angle can be in quadrant 4. Because those are the two quadrants in which sine is negative. And if sine is negative there, it's because y is negative. So we're looking at the y coordinate. It doesn't really matter if you know what 0.9273 radians looks like. All that matters here is that you know it's in quadrant 4. So this is the reference angle of 0.93. I'm just going to truncate this answer, abbreviate the answer as 0.93 rads. And then over here as well, we're going to draw a reference angle of 0.93. Now, a reference angle has no real direction to it, and you'll notice that I didn't put arrowheads on the ends of either of these two arcs, because a reference angle is just an angle. To find the rotation angle, what we're going to need to do is go one step further and look at an actual rotation to get there. So this would be a rotation angle. And over here, this would be a rotation angle. And you'll notice I did put an arrow on the end of each of these. We know that for this first case where the arm is in quadrant 3, we know that this distance in terms of an angle is pi. So to find out the green angle, which is the rotation angle in quadrant 3, what we can do is take pi and add that reference angle of 0.93 rads. Sorry, I'm getting used to the software on the smartboard, so it might take me a little while, and at times it might seem a little clunky, but I will pick up the pace. By the way, that reminds me, I should have told you this. This is all new to all of us. You know, you're watching this on a video on a YouTube channel. If at any point in time you feel I'm going too fast, then pause the video. If at any point in time you have a question, you obviously can't ask the question, but it's a good idea if you have a question to stop the video so that you can write the question down so you'll remember to ask later. When we take a look at the terminal arm landing in quadrant 4, we know that this total distance all the way around as an angle is 2 pi. So if we want to get to the rotation angle, which is in green, we can take 2 pi and we can subtract 0.93. Now we're asked to get answers in decimal form. So what we need to do now is take pi plus 0.93. And that literally means taking your calculator and taking that reference angle, I've already got it up here, and adding pi to the reference angle. Whoops. Let me do that again. Here's our reference angle, so I'm going to take pi and I'm going to add that to the reference angle. So I get 4.07 rads, we will say. We were asked to do this to 2 decimals, or to the nearest hundredth. So this is 4.07 rads. And then we can do the same thing over here. We're going to take 2 pi, but this time we're going to subtract that reference angle. So I'm just going to pull up the reference angle again. There it is. I'm going to take 2 multiplied by pi, and this time subtract the reference angle. So that means I get a second rotation angle of 3.36, I think I saw. 3.36 rads. Now again, this should be familiar to you. Pardon me, you get 5.36 rads. We'll just double check both of those. 4.07 and 5.36 looks okay. Now don't forget, and this should be familiar to you, what we've done is we've found the two rotation angles that lie within the first revolution, but since we're asked to find a general solution, we need to go further. In other words, everybody, these two solutions, both of these solutions are only in the domain of 0 to 2 pi. We're asked to find the solution over the domain of any real number. So our two answers are going to be 4.07 plus 2 pi n and 5.36 plus 2 pi n. I'm adding multiples of 2 pi to those two specific solutions to get a general solution. And of course, you then need to say that n is an integer. So that's a quick review of how to solve a very basic trigonometric equation. Now, the next lesson that we do tomorrow, we're going to need to know how to do this to move on, because tomorrow we're going to be doing quadratic trigonometric equations. That's the first example. Let's take a look at the second example now. We've got a rotation angle theta that lies in quadrant 3, and the tangent of the rotation angle is 7/4. You're asked to determine the exact value of the other 5 trigonometric ratios. So I will remind you here that tangent of a rotation angle is y/x. Cosine of a rotation angle is x/r. Sine of a rotation angle is y/r. And then we have the 3 reciprocal trigonometric ratios. Cotangent of theta is the reciprocal of tangent. Secant of theta is the reciprocal of cosine. And cosecant of theta is the reciprocal of sine. So look, everybody, in order for us to find the values of cos of theta, sine of theta, cosecant of theta, secant of theta, and cotangent of theta, it becomes pretty simple from a problem-solving standpoint. We need to know x, y, and r. And you're told that tangent of theta is 7/4. So let's talk about that for a second. Tangent of the rotation angle is equal to 7/4, but tangent of a rotation angle is y/x. Now you might make the mistake at this point of saying that I'm going to use x equals 4 and y equals 7. And it's certainly true that when you take 7 divided by 4, y divided by x, you will get what the tangent is equal to. But if you read the question carefully, it says that the angle lies in quadrant 3. So this is not correct. In quadrant 3, x is negative and y is negative. So if tangent of the angle is 7/4, and I just want to go back and just double check that, tangent of the angle is 7/4, then both x and y need to be negative because it lies in quadrant 3, and since they're negative, that's why we get a positive tangent. Now the only thing that's missing is we don't know what r is, but that's really kind of a trivial thing for us to find, because you should remember the relationship between x, y, and r. And it's that x squared plus y squared equals r squared. So it's pretty easy for us to work this out. We can put -4 quantity squared plus -7 quantity squared equals r squared, and we can evaluate the left-hand side. I think it's going to be 65, but I better check on the calculator. -4 squared, we want that in brackets. Of course, many of you just wouldn't use brackets as long as you leave the negative out. Plus -7 in brackets, quantity squared, gives us, 65. which means that if r squared is 65, r is equal to the square root of 65. And you can play around with the number 65 all day long. You're not going to discover a perfect square in it. So there's nothing we can do to simplify that, which means that r is root 65. So for us to determine now sine, cosine, secant, cosecant, cotangent, we're just going to use those numbers. I'm just going to go back to the previous page here where I had all of this written. Just so I can leave a little room for myself and see what x, y, and r are. And again, be patient with me as I work through this new software on this smartboard. What did we have? We had x equals -4, we had y equals -7, and we had r is equal to root 65. So it's going to be a little crowded, but that's okay. I will use a different color, something that will stand out. Tangent of theta will be equal to, well, we don't need to worry about tangent of theta, I guess. We already know what tangent of theta is. It's 7/4. Cosine of theta is x over r, so that would be -4 over root 65. That's cosine of theta. Sine of theta is y over r, which would be -7 over root 65. Cotangent is the reciprocal of tangent. Well, we already know tangent is 7/4, so cotangent has a value of 4/7. Secant is the reciprocal of cosine, so all we have to do is flip -4 over root 65 over and get negative root 65 over 4. We've talked about this in class. The reciprocal of -4 over root 65 is root 65 over -4, but I would just prefer to have the negative written on the top anyway. And then cosecant is the reciprocal of sine, so I flip sine over, which gives me the negative square root of 65 over 7. Some of you might be wondering if you have to rationalize the cosine and sine because they have denominators that have radicals, and I would say to you that it's really unimportant. So we covered two things here in this very short lesson. One is how to solve a very basic trigonometric equation like sine of theta equals -0.8 and come up with a general solution. We did that by finding a reference angle, then locating the appropriate quadrants where the sine was negative, then using those two diagrams to find rotation angles, and finally remembering that once you get the reference angles and the locations, to get the rotation angle, you have to, either in this case we added pi or took 2 pi and subtracted the reference angle. But in the end, we still had to add or subtract multiples of 2 pi to get a general solution. And that's it for today. Now, your first assignment is due Monday, April 6th. And if you were to go to the shared class folder, I'll show you what you would see. If you go into the shared class folder, now your folder is going to look different than mine. I've got a lot of stuff that you don't have access to. But when you go into the shared class folder, you're going to see a number of subfolders. And one of them is Math 30-1 assignments. And when you open that, you will see a folder within it called assignment number 1. And when you open that, you will see an assignment with your specific name on it. So just to show you what this assignment looks like, and I'm not going to talk about the content of the assignment, I just want to show you what it looks like. If you open this assignment up, it says Bethany. It's Bethany's assignment, assignment number 1, due April 6th. It turns out that the two questions are essentially the same as the questions that we just did in class together. But it is important for everybody to understand, and I'm not going to explain this every time. Whenever you do a step in mathematics on these assignments, you need to explain how you're going from one step to the next. If it's algebra, you need to show the algebra. If it's a matter of drawing two angles in quadrants 3 and 4, then you need to explain in words why the angles are being drawn in quadrants 3 and 4. So your work here needs to be organized, complete. You need to show all of your work. And what you're going to do when you're finished with this, you can either print out the assignment and do your work right on it, or you can do your work on a separate sheet of paper. But once you are done, you're going to take a picture of it with your phone, and you're going to email that picture to me. All assignments are due on the due date by 3:15. So that's it for today. Again, I wish we were working together face to face. I really do miss you guys, and I miss being in school with you, but we'll just have to make the best of a bad situation. So have a great rest of the day. If there's anything that you need, send me an email, and remember that you want to check into your Google Classroom every day to find out what's going on. So you're going to hear from me in a video tomorrow where we look at solving more complicated trigonometric equations. In the meantime, have a fantastic rest of the day, and we will talk to you later.